Influence of Gd+3 cation substitution on the functional properties of Al0.8La0.2TiO3 nanoparticles. Abstract. In present, the work reports on the effect of Gd substitution on aluminum lanthanum titanate, ALT, perovskite structures, structural and optical properties. The Al0.8 Gdy+La0.2TiO3, Y equals 0.01, 0.02, 0.03, 0.04, AGLTO. Hydrothermally synthesized nanoparticles. The Xrd indicates crystallite size, microstrain, dislocation density, and FWHM, full width half maxima. The Scherers formula and Williamson-Hall, WH, analysis used the X-ray peak expansion technique to determine the crystalline sizes and lattice strain. It was observed that an inversely proportional relationship exists. Fourier transforms infrared spectra, Ftir, tested the presence of Alo, Gdo, Lao, and Tio-based metal oxide, Mo, bonds at A and B sites. The Eg values are increased from 3.293 to 3.372 eV with increase of Gd content from Y equals 0.01 to 0.04. Contents show the wide Eg values suggesting optoelectronic and sensor applications. Introduction. The perovskite titanates doped with rare earth components offered fascinating structural, morphological, electrical, dielectric, magnetic, magnetocaloric and piezoelectric, etc., properties. 1. Numerous researchers focused on different properties of notable perovskite titanates like MtIO3, M equals Ba, Ni, Mg, senior, Pb, Al, La, Ca, Zn, Mn, Co, Eu, Zr, and so forth. 1. Among these titanates, the aluminum titanates, were concentrated in an exceptionally restricted way. Aluminum titanate perovskites were concentrated by past researchers 2 to 6 for primary, optical, photocatalytic, electrical, and mechanical properties. Specifically, Sahu et al. Arranged the AT nanoparticles and detailed the tetragonal design and dielectric properties. Azarnia et al. Fostered the AT nanoparticles just as nanofibers. Further, the inside and out microstructure was explored. Baxhande et al. Detailed the photocatalytic action of AT nanoparticles. Weiss et al. Separated the AT-based earthenware production from the aluminum sludge waste. Tang et al. Noticed the Goliath electro-rheological impacts in AT nanoparticles. From this review, unmistakably the writing on AT and its based nanomaterials was not accessible in a bountiful way. To expand the dielectric study of Al0.8La0.2TiO3, we wanted to substitute the Gd rare earth component. Consequently, the Al0.8 Gdy+La0.2TiO3, Y equals 0.01A0.04/AGLTO nanoparticles were arranged through aqueous strategy, wherein a few benefits like low working temperatures, less force, and tedious, great crystallinity, simple example planning, and modest were accomplished. 7. Experimental part. To set up the AGLTO nanoparticles, the trailblazer materials like La, NO3, 3.6H2O, 99.8% temperance, Sigma Aldrich, Al, NO3, 39H2O, 99.8% flawlessness, Sigma Aldrich, Gd, NO3, 3. 6H2O, 99.9% faultlessness, Sigma Aldrich, and TiO2, 99.9% temperance, Sigma Aldrich, were taken into another glass container containing refined water as per the stoichiometric extent. With the help of a peeling stirrer, the forerunner mix was blended at a consistent blending speed of 420 rpm. After some time, the white and blended nitrate game plan was outlined. Finally, the course of action was moved to another Teflon bowl of 300 ml limit. Thusly, the Teflon bowl containing the game plan was brought into the solidified steel autoclave. By then, to play out the watery reaction, the autoclave was kept inside the hot air oven for 8H at 150°C. Besides, the autoclave was chilled off to room temperature followed by the ejection of tests from the Teflon bowl. Accordingly, the test was cleaned for a couple of times until the pH worth of the model shows up at 7. In addition, using the hot air grill, the model was dried for 120 minutes at 60°A degrees C. Fittingly, the AGLTO nanoparticles gone through different depictions, for instance, X-ray diffractometer, Xrd, Bruker, Cu K equals 0.15406 nm, Ftir spectrophotometer, IR inclination 1, Shimadzu, and UV apparent spectrophotometer, JASCO, V670 PC, to ponder the underlying and optical properties, separately. Xrd Analysis. The X-ray diffraction patterns of AGLTO nanoparticles are recording as shown in Fig.1. These patterns provided multiple number of diffraction peaks indicating the polycrystalline nature. It is observed that the maximum intensity is recorded at 2 theta angle 13.47220 for all the samples. From the maximum intensity, Imax, data, see table point 1, it's find that the intensity of the maximum peak position is increased from 6,155 to 11,840 with increase of Gd content in the Al0.8La0.2TiO3 system. Therefore, it is confirmed that the substitution of Gd element induced the crystallinity of Al0.8La0.2TiO3. However, it's noticed that these peak positions are not matched with any standard structure. Herein, the peak positions of x equals 0.010.04 contents are identifying to be the dimensions of the building block will be decreased. These results can be attributed to the significant homogeneity of the prepared AGLTO nanoparticles shown in table point 1, where dislocation density shows the values between 5.806 x 1014 and 18.57 x 1014 m2 respectively. An alternative form of the Gd contents is y equals 0.01 to 0.04. This trend is attributed to the molecular weight of the sample is that raise from 145.412 to 145.963 g/mol as a content with y. Williamson-Hall, WAH, plot, Fig.3, is a known planning tool for estimating the average size of crystals, d, and fine deformation. WH schemas are developed between cos versus 4sin of the current study using compatible linear relationships. And the intercept value is related to the crystallite size, d. The resulting values and d are listed in Table 1. Finally, a good agreement is noticed between the values derived from the WAH plots based on Scherers theory and the values and d. Based on the formula x equals 0.01 to 0.02, d increases and x equals 0.03 minus 0.04 decreases d. Microstrain is decreases from x equals 0.01 a 0.03 after x equals 0.04 increase 11. It can be seen in Fig.2 that there is an inverse proportional relationship between the two parameters d and 10. In literature, similar types of results have been published. 9 to 12. Uvis Analysis. In order to calculate the optical energy gap, e.g., the Kubel-Communk function is considered. Using this, the function of reflectance f, r, 1r, 2/2r, where r equals reflectance which is recorded from diffuse reflectance spectra as shown in the inset of Fig.4 is computed 13. Herein, the f, r, is observed to be directly proportional to the absorptivity, and therefore, in place of its can substitute f, r. Further, using the equation, h, n equals m, heg, and the, h, n versus photon energy, h, plots, it is calculating the Eg values of AGLT. The exponent, n, in the band gap equation is taken as 2 for direct transition of charge carriers between two energy bands 13. The, h, n versus h plots of x equals 0.01 to 0.04 contents showed the linear portions. These linear portions are extrapolated towards the h-axis. Then, using the intersecting position of the straight line at the h-axis, wherein approaches to 0, the Eg values are calculated. These Eg values are indexed in Fig.4. The results indicates that the Eg values are increased from 3.293 to 3.372 eV with increase of Gd content from x equals 0.01 to 0.04. This kind of behavior is mainly attributed to the oxygen vacancies present in the each composition. That Ftir analysis. The Fourier transform infrared spectra, Ftir, spectra of AGLT nanoparticles are recorded over 4000 A400 cm1 wave number range and show in Fig.5. The A and B site locations are indexed using the A and B. These two positions suggest indirectly the formation of perovskite structure. The A and B peaks are noticed during the range of 590 to 613 cm1 and 450 to 462 cm1, respectively, see Table 3. The formation of A and B absorption bands revealed the existence of the metal oxide, MO, ALO, LATO, GDO, TIO, stretching vibrations 8, 14. Besides, the additional bands recorded at 720 to 736 cm1 are also associated with the metal oxide bonds of parent perovskite. During 1057 to 1069 cm1 and 3072 to 3617 cm1 wave number range, the peaks are tailored owing to the OH stretching and bending vibrations of H2O molecules absorbed by the AGLTO nanoparticles 8, 14. This implied that all the contents are affected with moisture up to smaller extent. Vacancy and vice versa 13. In case of AGLT nanoflowers, the numbers of oxygen vacancy are decreased with increase FGD content. Therefore, the concerned distances between the valence and conduction bands are increased from 3.293 to 3.372 eV, see Table 2. However, the x equals 0.01 to 0.04 contents show the wide Eg values suggesting optoelectronic and sensor applications 13. Conclusion. The AGLTO nanoparticles were prepared using the hydrothermal method. The Xrd patterns of all samples indicated the highest peak at 13.472 A. Also, the average crystallite size, D, was noted to be changing from 23.2 to 41.5 nm for AGLTO samples. The dislocation density values are between 5.806 x 1014 and 18.57 x 1014 m2 respectively. An alternative form of the Gd contents is y equals 0.01 to 0.04. The WAH plots based on Scherers theory and the values and D is a good agreement is. Furthermore, the optical band gap, e.g., was found to be increasing from 3.293 to 3.372 eV as a function of y. The formation of A and B absorption bands revealed the existence of the MO stretching vibrations.